AI is without a doubt one of the most powerful tools we've ever created. But, a really concerning pattern is starting to pop up in the business world. Companies are scrambling to get on the AI train, but in their rush, a lot of them are setting themselves up for a very specific and completely avoidable type of failure. And yeah, this quote from Ben Piper, it just hits the nail on the head. AI isn't some magic wand you can wave to fix a bad process. It's an amplifier. It takes whatever you give it and makes it bigger. So if you feed it a broken, messy, undefined process, well, you're just going to get a bigger, faster, and way more chaotic broken process. So why do so many people fall into this trap? Well, it usually comes down to this big myth, the idea of a truly autonomous AI that can just figure things out on its own, with no human in charge. We really have to be crystal clear about who's doing what. Think of it this way. In a human-in-the-loop system, the AI is your smart assistant. It suggests things, it drafts things, but the human makes the final call and takes responsibility. But in an AI-in-the-loop system, the roles are flipped. The AI makes the decision, and a human just kind of watches. For anything important, that is a recipe for disaster, because when the AI inevitably makes a mistake, those errors can spiral out of control fast. The rule has to be, AI advises, the human decides, period. I absolutely love this smart toddler analogy. It's just perfect. AI is incredibly powerful, right? It can do things that seem like magic. But like a toddler, it has no real-world understanding of consequences or goals. So if you leave it unsupervised in a critical system, you better believe it's going to make a huge mess. You have to build your systems with the assumption that a human is there to provide direction and, yeah, clean up. Okay, so that leads us right into our next point, which is, well, it's a rule as old as computers themselves, but it has never been more important than it is right now with AI. You see, with regular old software, if something goes wrong, you can pop the hood, look at the code, and see exactly why it did what it did. But with AI, not so much. We call them black boxes for a reason. You see what goes in, you see what comes out, but the logic inside, the why, is often a complete mystery. And if you can't see the reasoning, then the quality of what you put in is pretty much the only control you have. And that brings us right back to that timeless rule. People have this hope, this dream, that AI will just magically clean up their messy databases and spreadsheets. Nope, it absolutely will not. It cannot turn garbage into gold. It will just confidently produce outputs that are, well, garbage flavored. Your model is only ever as good as the data you feed it. That's it. So, I can talk about this all day, but let's actually see it in action. We're going to run a little experiment. Asking an AI to do something that seems super simple. Just validate some user data. All right, first up, we feed the model some basic data, a valid name, John Doe, and a phone number that's obviously wrong. And hey, it works. The model correctly flags the invalid phone number. So far, so good. Looks great, right? What could possibly go wrong? But, and this is the crazy part, watch what happens when we run the exact same input a second time. We haven't changed a single character. And boom, suddenly the model says the data is totally valid. The same phone number it just said was an error is now perfectly fine. This is the problem right here. It's not deterministic. So what gives? The inputs are identical. Why two totally different answers to the exact same question? The scary truth is we don't really know because it's a black box. And if you're a business and you can't explain why a transaction was approved or why it was denied, you've got a massive reliability and compliance problem on your hands. Oh, but wait, it gets even better. Let's try giving it a very clear, explicit rule. The name length can be unlimited. The model seems to get it, but then it just makes up a rule out of thin air. It says, the system enforces a 50-character limit. What system? There is no system. It's hallucinating, inventing constraints based on patterns it saw in its training data, and completely ignoring our direct instruction. Okay, so right about now, you might be thinking, sure, but AI is getting better all the time. These are just growing pains. This will fix itself. And that's where you'd be missing the fundamental point about what these models actually are. It's not about them being good enough. This is probably the best analogy I've ever heard for it. Think about an MP3 file. You start with a perfect, lossless audio file, and you compress it down to an MP3. It sounds pretty good, right? It's a very useful model of the original song, but you've thrown away data to make it small. You can never, ever get that original perfect quality back. That information is gone forever. An AI model is just like that MP3. It's a lossy, compressed, imperfect representation of reality. It's not the real thing. Let's put this to the test with some super simple math, something a basic calculator could do in its sleep. We're going to train a model on a perfect, straightforward formula. Y equals 2x minus 1. We'll give it a few perfect examples to learn from. Now, we ask it for a big number, something way outside the data it's seen before. The correct answer is 199,999. The model gives us 199,995. So close, but, still wrong. And this is the key takeaway right here. The model didn't fail. It actually did its job perfectly, which is to approximate a pattern. We failed. We failed by using a probabilistic tool, a tool for guessing, for a task that demands absolute deterministic precision. We used the wrong tool for the job. So, this all begs the question, how do we make sure we're always picking the right tool? Well, it comes down to understanding the basic, fundamental difference between regular programming and AI. And really, it boils down to this. This chart says it all. On one side, you have traditional programming. You write the rules. It's predictable, it's deterministic. You use it when you need precision and zero mistakes. On the other hand, you have AI. You give it a ton of examples, and the machine guesses the rule. It's unpredictable and probabilistic. You use it for fuzzy, ambiguous problems like recognizing complex patterns. So look, before you even think about starting an AI project, you need to sit down with your team and be able to answer these 4 questions, no exceptions. Who makes the final call, a human or the machine? Is the AI an advisor or an automator? Where are the exact points a human has to step in? And maybe most importantly, what's your plan B? What's your rollback plan for when, not if, the model messes up? All right, so let's wrap this all up. What are the big takeaways here? First, fix your process before you throw AI at it. Second, treat AI like a tool, not a mind. It's not thinking. Third, always design for human oversight. Fourth, use good old-fashioned code when you need precision. And finally, save AI for what it's great at, finding patterns in complex, fuzzy data. And that really points to the future we should be aiming for. BenPiper puts it perfectly here. It's not about AI replacing code. It's about these two incredibly powerful approaches living side by side, coexisting, with each one playing to its unique strengths. So I'll leave you with this one final thought. For your next project, your next big idea, really ask yourself, is AI truly the best tool for this job? Or are you just reaching for the newest, shiniest tool in the box? Because choosing wisely makes all the difference.